say compared to any other routing protocol in use today, the advantage of EIGRP is that it has a backup path. It all that has a feasible successor. So say for a particular prefix, there is another way to reach. The EIGRP places that in its table ready, in EIGRP table ready. Once the current successor goes down, the current neighbor goes down. So immediately, without doing any checking, the backup path is placed in the routing table. So this is how it is called the fast convergence compared to any other routing protocol. If some network goes away, the other routing protocols has to reconverge to find that network, but EIGRP doesn't need that. Actually, it immediately places the feasible successor in the routing table, so it can continue forward in the table. It can continue forward in the traffic. Feasible condition is used to select loop-free backup path. Subsequent reconvergence when primary path fails. This you can consider it as a backup path. When primary path fails, immediately the second backup path is placed without checking anything, without speaking to neighbor, without asking him whether it's available or not. Without doing that, it's immediately placed. Fault isolation. Yeah, once the fault is then immediately this is placed, and this also helps in unequal cost load distribution. This is another feature which no other routing protocols provide. Say we have two paths, one path with one metric and another path with another metric, say one path with some higher bandwidth, another path with lower bandwidth. We still can use both the links proportional to their bandwidth. We do that with the variance command. I'll tell you in a successive slide. So first, the best path is called successor. Take the metric of the best path as x. Next, find the alternate backup paths. Anyone with a metric less than x is closer to the destination than me. Exclude anyone with a metric greater than or equal to x. Let me tell you, before knowing feasible successor, we should know about few terms. Let me tell you those things. Reported distance. Reported distance is the total distance along a path to a destination network as advertised by an upstream peer. Say you consider this one topology. Say loopback 0, to reach loopback 0, R1 says I can reach loopback 0 with so much metric, so and so metric. That is called the reported distance. For R2, R1 says I can reach loopback 0, I can reach 1.1.1. network with so much metric. But R2 has to calculate this distance to get the total distance. But before adding that, whatever R1 reports to R2, that is called reported distance. So next is feasible distance. Next is called feasible distance. Feasible distance is the lowest distance to a particular destination. That is, it is reportable distance plus link cost to reach the upstream peer. So this is again whatever the router which reports the best distance to reach a particular destination. Say R1 gives some distance to reach one network, and R3 gives some distance to reach one network. Whoever's reported distance plus the distance to reach that router together, if is lowest, is the best metric, that distance is called feasible distance. Whichever route is having the best feasible distance, that is placed in the routing table of EIGRP. That is placed in EIGRP table. Next is feasibility condition. If a router's reported distance is less than our feasible distance, feasible distance is the total distance to reach a particular prefix. If some router tells it can reach that prefix with some distance which is less than the total distance what we are taking, then that is considered as a backup path. So this is a logic actually. If we are using the same path, then it would be greater than whatever the distance whatever we are using. So it would be greater than whatever the reported distance we have from other neighbor. So if it's a loop-free path, it should be a smaller distance. I'll show you in further slide what it means. And next terminology is a feasible successor. A route is a feasible successor if it satisfies the feasible condition for a particular destination. Successor, a route is a successor if it satisfies the feasibility condition and it provides the lowest distance to the destination. So the best path whatever we have is called successor, and the backup path to reach the particular prefix, we call him as the feasible successor. Active and passive state are, say, if some prefix is not available, we call it as an active state. If some prefix is available, which means we are able to reach that neighbor, then it's called a passive state. Passive state. All routes which we are in, whichever routes are prefixes which are in passive state, those are called passive. Means which are up and running, those are called passive state prefixes. Okay, when you give a show IP EIGRP address family, these are the things. If you see the topology table, you see a P here, which means the passive route it is. And this is the two distances what you see. One is computed distance. Computed distance is the total distance to reach that neighbor and that prefix. Reported distance is the distance to reach that prefix by that particular router. It is with respect to the neighbor router. This is with respect to V or this router. So successor is the route which is having a better metric. You can see this, and computed distance is having a little bit more than that, but you can see the feasibility distance here, 210, 2650. This is the feasibility distance. Feasibility distance is the total distance taken to reach that particular prefix. So 1 minute. So here the reported distance is 2051, but the current feasible distance is 2102. So this is less than this. So this can be placed as a feasible successor. So this is one of the topology where we can try to understand the feasibility condition. This some mistake happened. It's router B. This is router A. This is router B, router C, router D, and router E. Router A wants to reach router E. So the metric to reach this A to B is 10 and B to E is 10. So the total distance for A to reach E is 20, and this is 15 and this is 10. This path will give us 25, and this is 15 and this is 30. This will give us total distance as 45. So the B's reported distance to reach A is 10, C's reported distance to reach E is 10, and D's reported distance to reach D's reported distance to reach E is 30. So since this is the lowest metric path, this is called a successor. The 10 plus 10 is 20. So now we have to check which will be the backup path for us, which we can have as the feasible successor. So the definition says the reported distance should be less than the feasible distance. The feasible distance is the 10 plus 10 is 20. C reports the distance as 10. D reports distance as 30. So 10 is less than 10 plus 10. 10 is less than 20. So C holds good for feasible successor. D to E is 30. 30 is not less than 10 plus 10. So D to E cannot be a feasible successor. So C is placed as the feasible successor. So say you think a condition A to B connection goes down, immediately A to C, A starts using C because it is placed in its EIGRP topology table, very much prepared as a feasible successor. So just think A to C also goes down. So once A to C is up, so 10 plus 15 is 25. So still D reports the distance as to reach E as 30. So which means 25, 30 is not less than 25. So D will be not placed as a feasible successor. Once A to B is down, we will be having only one route in our network table, in our topology table, that is A to C to reach E. Though we have an alternate path to reach from A to D to E, but that will be not placed as a feasible successor because the reported distance is more than the current feasible distance. So say once A to C goes down, so A doesn't have a backup path now. It starts sending query to all its neighbors. So it has 3 neighbors B, C, D, 2 neighbors are down. It has only 1 neighbor. Now it sends a query message to D asking, do you know how to reach the network connected to E? D will tell the current path whatever it is using. This is not disturbed, so D will share its path, and A doesn't have any option to compare the best or whatever. It listens only from D and it starts using the D path. The only delay what we have is from A has to query D and D has to reply to that. But when A to B goes down, A doesn't speak to C immediately. A starts using C. So that is called fast convergence, what we have with feasible successor. So do anybody have any doubts about feasible successor?